Hello friends, Eli Hibbett here with the Pwn Your Homework Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in.
Alright, how is everybody feeling today? I am your host Eli Hibbett with today's Pwn Your Homework Physics Series podcast, and today's episode is Radians and Degrees. I've been really excited. I wanted to do this podcast for a while because I think in the month of October, if we're going to keep with our spooky theme, with the new spooky music, this is a great topic because there's a lot of different patterns and kind of interesting symmetries about radians and degrees and the circle and all that stuff. So I've been pumped and been thinking about it for about a month now. So I hope you like it. We're going to have some cool little extras on pwnyourhw.blogspot.com. So check it out over there. What am I working on? I'm working on a new app called Sines and Cosines, which goes through in a little more detail exactly what sines and cosines are. It's not just a little wave-like curve that actually has a really meticulous definition, and it's very interesting. So I try to take that and put it into an app form, and then also give it something that you can review and use in your physical and mathematical life. So that's going to be coming in November. I don't think there's there may be too much there to do in a single episode, so we might break that up into two parts in our November month. And next week is Halloween week, so I'll be doing a Halloween-themed podcast. I haven't quite decided what the theme's going to be, but it's going to be more spooky-themed. It's not going to be covering a specific topic, so just wait till next week and we'll see what it is. One other thing I wanted to mention on Twitter, 2718 Productions, a lot of times I use that space to work out some ideas for future apps. So it's a kind of an interesting place to check out because there's always little tips and step-by-steps floating around there. So if you're looking for a little more, a little extra, check out the Twitter feed. Some cool stuff there. So, song of the day this week is Arrestus by A Perfect Circle. They have a new compilation album out called 360, which I thought was perfect for our Radians and Degrees podcast for today. And they're also called Perfect Circle, which is great. And these lyrics also mention the circle. So here we go. Here is the tie-in musical clip of the day. I'm a big Perfect Circle fan, and that song, I think, is my favorite song by them. So in the show notes, I'll include a full link, YouTube video of that song if you like it. That's a great band. Great turn of the century, early 1990s, or late 1990s, early 2000s band. So if you like that, check it out. Next up, we're going to have the quote of the week, which is by our man Nikola Tesla. And he says, "If you only knew the magnificence of 3, 6, and 9, you would have a key to the universe." This is a very interesting quote. There is some discrepancy or controversy as to whether he actually said it, but he was kind of a creepy guy. And, the quote may be a hoax, but it's kind of interesting. I've been checking out some videos on what's known as vortex mathematics and how 3, 6, and 9 are really related, and how 3 and 6 are kind of back and forth polarity-wise, and 9 is like an axis between all the numbers. And it's kind of like hippie-ish stuff, but it's very interesting. So on pwnyourhw.blogspot.com, I have a link to a video which is called 369, and it mentions this quote about Tesla, and then why there's 360 degrees in the triangle or in a circle, and how if you add 360 you get 9, and if you subdivide it 180 you get 9, and if you add up all the numbers all the way down you continue to get 9, which is a very interesting feature. And so if you think about why he talks about 3, 6, and 9, I mean, they're obviously multiples of 3, and there's 3 of them there, I guess, within our base 10 number system. And so a lot of things in our universe actually have 3 parts. We have 3 spatial dimensions. Tesla was famous for creating 3-phase electric current, or electric power, his AC, alternating current. And then we also have the proton, the electron, and the neutron, as fundamental particles of the atom. And so it's kind of interesting. I mean, even if it's not necessarily his, it definitely gives it maybe a little pseudoscientific, but definitely gets you thinking and keeps you interested. So, anyways, enough about that. Let's get into the meat and potatoes of this podcast because we got a lot to cover today. And the topic of this podcast is radians and degrees. And I know that a lot of beginning physics students have trouble with radians. I think 360, we talk about degrees a lot in our life, 45 degree angles, 30, 60, 90 triangles, stuff like that. And people are a little more comfortable with degrees, I think, because we use it a lot more. And radians is a very confusing topic. And once you start talking about radians, and then all of your sines and cosines that you calculate have to be in radians, and why is everything in radians? What is radians? What is pi over 6 radians? Pi is an irrational number. How can you divide it into 6 equal parts? Blah, blah, blah. And so I think this is a really important topic that, if you understand it correctly, will really give you a great understanding of how the physical world works and why you compute things in radians, why this makes sense, and how it's related to the circle. And this is really critical for setting us up for understanding sines and cosines. And I think sines and cosines are the next big question mark where people kind of just say, okay, I know the sine of 0 is 0, and they don't really start thinking about exactly how these relationships form and what the underlying ideas are. And that's really critical to taking what you know to the next level. So this is really the foundation of that. So if we can understand degrees and radians and be able to convert fluidly between them and understand a little bit more about radians, I think we're going to be set up and on the right track. So just to give a little bit of formal definition, we'll first define a circle. And what is a circle? A circle is a locus or group of points, all of whom are equidistant from a center point. So most people know that there are 360 degrees in a circle if you measure the angle all the way around. And the distance from the center point to any point of the circle is known as a radius. So those three things I think are really critical. So we know that a circle is a group of equidistant points. A distance from any point to the center is called the radius. And if you take let's say the horizontal, and let's say the plus x direction, if you know which way the positive x direction is, but it doesn't really matter. If you measure any angle, you'll start with 0 and it'll get bigger, and if you go all the way around the circle, you will approach 360 degrees. And so we know that there are 360 degrees in a circle. And we also know that the distance around a circle, the perimeter, I guess you'd say, of the circle is known as the circumference. And so this distance is related to the radius. If you divide the circumference by the radius, you get this magical number pi. And pi is an irrational number, and it is 3.1415926535589 ... and it goes on forever. And you can look at wonderful resources online that show you pi to 100 decimal places to 1,000,000 decimal places. And interestingly enough, there is a little group of 6 nines, which are referred to as the Feynman point, because Richard Feynman, my main man, was one of the first people to take a look at that and say that was kind of interesting because, truly irrational numbers don't generally have clusters of repeating digits. And so he said, the 6 nines is kind of interesting. And what he wanted to do was be able to memorize the first 762 decimal points of pi so that he could say all of them and then say, 9999999 and so on. And, this is kind of his sense of humor. I thought that was kind of interesting. But this is what pi is. Pi is this long, irrational number, and the better you can measure the circumference and the radius of a circle, the better you can actually measure pi and calculate it. So pi is the ratio. It is part of the ratio of circumference to radius. But if you wanted to calculate the circumference, you say the circumference is equal to pi d, or more conveniently, 2 pi r. So it's actually, the pi is the ratio of the circumference divided by 2 times the radius, or the diameter of a circle. And the diameter is 2 times the radius, or if you go from one point on the circle to the other point directly across with that distance, it's called the diameter. So I think you need to know those things to really understand exactly what we're talking about here with radians. Because the next topic I want to introduce is what's known as the unit circle. And this is a very convenient circle in mathematics. We say that this is a circle whose radius is 1 unit. It doesn't matter what unit it is, just unit of 1, and that simplifies everything quite a bit. Because in math, I don't like to use units very much, because everything's very abstract. And so, with a radius of 1, we kind of get to drop out this r, and we say that the circumference is 2 pi. Which means if you start at your 0 point, and you measure the distance all the way around the circle, you're going to get 2 pi as your distance. And so, instead of using 360 degrees, we can use what is known as radians, or this relationship with the radius. And we say that instead of 360 degrees, we have 2 pi radians in a circle. And so, okay, if we have 2 pi radians is equal to 360 degrees, that means that 180 degrees is equal to pi radians. And if you listen to one of the earlier podcasts about unit conversion, this is our conversion factor. We can say pi radians over 180 degrees or 180 degrees over pi radians. And we can use this to convert back and forth between pi, radians, and degrees. So one kind of interesting thing that this video that I linked up on the blog talks a little bit about. It asks, why are there 360 degrees in a circle? And it's kind of an interesting question because it's not a nice round number, and it seems kind of arbitrary. Why would you want to use that many to measure around a circle? Why is 45 degrees special or anything like that? And nobody really knows exactly how this came to be as our convention, but 360 is evenly divisible by 1, 2, 3, 4, 5, 6, 8, 9, and 10. And we know that our calendar year is also 365 days, which is roughly 360 days. And there are some ancient calendars which have 360 days in them. And so, as opposed to our current calendar, which has 365 days, this 360 is very nicely divisible. And since a lot of ancient measurement was done mentally, they liked having things that were very nicely divisible. And so if you can divide things with that many numbers, it's going to be very convenient for you to measure very many angles and do very simple calculations. I think something that's very interesting about this to note is that the only number between 1 and 10 which does not evenly divide into 360 is the number 7, which is how many days are in our week. And why that is, I'm still a little curious, but it seems kind of convenient, But but most likely the 360 degrees also relates to our calendar year because ancient people were very obsessed with timekeeping and the orbit of the Earth around the Sun. So very likely that's where it came from. But a very interesting thing about radians is that you never really refer to an exact decimal amount of radians. You never say, okay, I have 1.56 radians or 1.5 radians, something like that. You usually, everything in radians is referred to as some fraction of pi. And for example, so let's say we take 30 degrees and we want to find out how many radians that is. We don't really do a calculation. We use our conversion factor. We take 30 degrees and we multiply by pi radians divided by 180 degrees. And what this does is simplifies down into pi over 6 radians. And so most things are referred to as some multiple of pi. And so what you're doing is you're just saying how many parts the circle is divided into. 30 degrees is equal to pi over 6 radians, or the circle divided into 12 parts. 45 degrees is pi over 4 radians, or 180 degrees, or half a circle divided into 4 equal parts. 60 degrees is pi over 3 radians, or half a circle divided into 3 equal parts. 90 degrees, pi over 2 radians. 180 degrees is pi radians, as we've talked about before. 270 degrees is a very common degree that you're going to need to use, especially with sines and cosines, which is 3 pi over 2 radians. And 360 degrees is our full 2 pi radians. These are the most common angles that you'll use. And so I think that you really need to make sure that you're familiar with them and their radian counterparts. So the more conversion factors you do and the more calculations you do, you're going to get used to this. In the meantime, until you kind of get up to speed with it, I have an app in the App Store which covers this. It's called Exploring Physics, Radians to Degrees. And I have a list of the common angles in degrees and radians. And then as you tap them, there's a tapper view which shows you the conversion into radians and degrees, vice versa. Flashcards which give you review in that way, to kind of test your knowledge. And then there's also a tap quiz, which gives you, multiple choice answers, and you can kind of go through that to get you up to speed and to really train your brain to start thinking this way, because you're going to be using Radians a lot in your physical career. So get used to it, get familiar, become a master of Radians, get to know the circle, because as Nikola Tesla says, if you only knew the significance of 3, 6, and 9, you would have the key to the universe. So that is our review of Radians and degrees. If you need more assistance, check out the app. It's really useful, and I'm not just schlepping it here. This is a really important thing that you need to know inside out, backwards, and forwards for at least your first semester, and it'll just work its way into your brain as they hammer you through the next 8 semesters of your college career. So it's worth checking out and going through the flashcards while you're sitting on the bus until you get really, really good at it. So check out the app. And I think that's going to do it. pwnyourhw.blogspot.com. Give me a tweet at 2718productions. Let me know what you're thinking. And yeah, I'll catch you on the flip side. Take care, guys. See you next week. Halloween episode.